Okay? So what are we trying to answer no to? We're trying to answer no to the fact that it's not similar. So then it makes us think about, okay, what is the meaning of similarity? What do we look for when it comes to similarity? Okay, we're looking at certain properties, right? Okay, that's why I kept on going through with you what is the meaning of similar figures. And you always tell me one thing about the angles, which is the corresponding angles are equal. Okay, so that is one qualifier. Okay, and then another qualifier is that the sides, what about it? The length of sides. They are equal or similar? They are. The ratio of the length of the corresponding sides is equal. Okay, so we need to be clear about this, about the angles and then also about the length of sides. So in this case, we are not given any information about length of sides. That means we should just only be looking at the angles itself. So what we want to then check is the corresponding angles. Are they equal or not? So that shall be your basis for explanation. You understand? Okay, so you need to think about what is your qualifier. Okay, what is the situation you're looking at? What are you trying to answer? Okay, what is the meaning of this word itself? Alright, so looking at the angles, how they correspond, they are both isosceles triangle. We are looking at triangle CAB and, the question was triangle ABC with PQR. Okay, ABC, if you were to rotate it into the same orientation as this, it would look like that. So it's either you check whether the angle over here is it 40 degrees or not, or whether the angle over here is it 50 degrees or not. So there are two options that you can take. So let's say if I want to go and find out what is angle QPR, that will be 180 minus 50 minus 50. That gives us 80 degrees. Due to your base angles of isosceles triangles, as well as the angle sum of triangles. There are two reasons, because the other side is 50 due to base angles of isosceles triangle. To find this one, it is an application of your angle sum of triangle. Okay, so we see the angle QPR is not equals to your angle BAC. Okay, so we say that since these two angles are not equal, then the corresponding angles are not equal. Therefore, triangle ABC is not similar to triangle PQR. Okay, so that will be how we form our explanation. corresponding length of sides. Okay, so therefore, the next thing we need to check is the corresponding length of sides. But then, maybe let's complete the angle part first. Right here. Corresponding angles are equal. Okay. And then we now check the ratio of the length of sides. DE corresponds to ST, which is 3.2 divided by 1.6, that's 2. I'm quite sure I did something similar before in couple of examples. DF corresponds to SU, so 5.4 divided by 2.7, that's 2 as well. EF corresponds to TU, which is also 2. So therefore, the ratio of the corresponding sides of the length of house is similar to this house. Okay, so the corresponding side y, what would it be on the other side of this? 180, right? So we can form our ratio y over 180 to be equals to, we need another complete pair. So it is equals to what to this? Y corresponds to 180 form one pair. What is a complete pair? 180 to 120. So there we can find y, right? It needs this one to solve more. Okay, next one, z. Okay, we want to find z. So z is this side over here. Notice that there's nothing, no information given over here. But let's use some common sense to think. This is a house. Okay. This length is equal to what on the same house? It should be equal to this length. It should also be equal to this length, right? Can you imagine if this, and this they are not equal, your house will be lopsided. Right or not? Okay. So WZCM corresponds to this side, and this side, they're all equal. So they're all 150. Okay, so are we able to solve for Z3D? Can, right? Okay, so I will not complete now. So work it out. Next, question 7. They all depend on the scale. Scales, we have different versions. We have one that is of a statement, 1 cm representing 10 kilometers. I just write it in short, in case you don't understand. Okay. An example of a scale is 1 cm representing 10 kilometers. An alternative to such representation of a scale is that we can have it in ratio form. In ratio form, we need to ensure that the units are the same. So if this were to be in cm, okay, then my 10 kilometer need to be converted into cm as well. So that will be times 100,000, okay, because times 1,000 to become meter, times another 100 becomes cm. So that gives us 1 million. So they are equivalent by nature, just a different way of writing, right? Then we also saw situations whereby we are given a diagram, okay, and then we needed to measure, okay, then this is 10 km, which is 1 cm itself, okay, if I use a ruler, okay, so I'm not drawing it in one, I hope you get what I mean. And then we also have the representative fraction time. Okay, whereby instead of writing it in a ratio form, we write it as a fraction. In other cases, we always have it written such that it is the map first, followed by the actual. Okay, so we always have the map on the left-hand side followed by the actual. But even if we forget that, we can use our common sense, okay, to look at it. Since we know how long 10 kilometers is, realistically speaking, it doesn't make sense that this is the map and then this is the actual, right? So yesterday we were looking at how do we calculate length. Okay, we looked at practice now 12, question 2 already, right? Okay, we look at the length, okay, on how to do it. I finished the question already, right? Okay. So today we're going to look at area. Okay, will the same scale actually apply to area itself? Right? Let's think about it. If let's say I have a 1 cm by 1 cm square, and I am using a scale of 1 cm representing 10 kilometer. That means that in reality, sorry, I cannot draw a 10 kilometer size square, but let's imagine this to be the actual. Okay. So this is what appears on the map, 1 cm by 1 cm. That means in reality, right, the square is 10 kilometers by 10 kilometers. Okay. The area of the square on the map, what would it be? We know the area of square, right? Length times breadth, 1 cm times 1 cm, right? Which will be actually an area of 1 cm square, because 1 times 1 is 1 cm, 1 cm square. But for the area of the actual, okay, it will be 10 kilometer times 10 kilometer, and that results in 100 kilometer square. So in other words, okay, we see that a 1 cm square on the map itself does not represent 10 kilometer square. This is our length scale. Length, we know 1 cm represents 10 km. But when it comes to area, 1 cm square represents 100 kilometer square in its actual size. Okay? So what I'm trying to say over here is that your length scale differs from your area scale. Okay? So your area scale and your length scale cannot be the same. It will not be of the same ratio. Understand what I'm trying to say? Okay? So what if it is not 1 cm by 1 cm, 10 km by 10 km? I can always change it, right? Okay, let's say if I have 3 cm by 3 cm. With the same length scale, And the area of the electrode will be 30 kilometer times 30 kilometer, which is 900 kilometers squared. What this tells us is that 9 cm squared represents 900 kilometers squared. If I were to simplify this, dividing by 9, I will get 1 cm squared representing 100 kilometers squared. Right? If 9 cm squared represents 900 kilometers squared, 1 cm squared will represent 100 kilometers squared as well. Are you all following what I'm saying? Okay. So, what does this mean? This itself is our length scale. If I want to find out the area scale, okay, to know what is the area scale itself, what I need to do is I square the length scale. Okay, I square it in the sense that I get 1 square cm square representing 10 square km square. Because 1 square, 1 times 1 is 1. 10 square is 10 times 10 is 100 kilometers. Okay, so that is how we achieve the area scale from the length scale itself for our calculation. Okay. So this itself is just an explanation to you to justify that I cannot use the length scale to find area. I need an area scale for finding area. Okay, that's what I'm trying to say. Right, I'm going to erase this. Look at an example. Let's look at practice now 13, question 1. Square get the area scale. Okay, it is not that simple when it comes to kilometer square, meter square, centimeter square. Neither is it going to be simple for kilometer cube, meter cube, centimeter cube. Right? In fact, your kilometer cube, meter cube, centimeter cube, you'll do that next year in section. Okay? So what you can do is, with that confidence that kilometer to meter is times 1,000, we see that 1 cm represents 2,000 meters. So I just head towards meters first. Okay? Then I go into doing my area scale. 1 square cm square, 2,000 square meter square. Okay? And that will give me 1 cm square, 4 million meter square. Okay? And then notice that it is the same process. Okay? So the process remains the same. approach in answering the question, because you notice there's plenty of zeros. And furthermore, you need to be mindful of conversion from centimeter square to kilometer square. Okay? What I personally have done is that given the map and the actual is 5 cm to 1 kilometer, okay, I can find out what is 1 cm to the kilometer first, which is 1/5 kilometer. Because my goal is to find out in kilometer square, that's why I decided to choose this instead. Then now I need to find the area scale. That will be 1 square cm square, 1/5 square kilometer square. 1/5 is, by the way, 0.2, so that is 0.04 kilometer square. Okay, so 1 cm square is 0.04. Notice that I actually write lesser number of zeros